Mining Weekly Online is interviewing Keith Liddell, the inventor of the Kell process, which slashes electricity consumption and eliminates the power-guzzling smelting step in the processing of platinum group metals. Keith, can you tell us what is this Kell process?
Well, essentially it's a hydrometallurgical process, which means that we leach the platinum and the base metals out of the concentrates that that mines produce, rather than current technology, which is you take the concentrate and melt it at 1600 degrees C. So it's a completely different processing route.
And how did you discover it, and why are you calling it Kell?
Well, the first one is I used to be MD of a junior platinum company in the late 90s, and it was difficult to break into the market because we weren't producing enough to build a smelter. So I started to look for alternatives to smelting there in the late 90s and actually patented the process 1999. So it's going back a few years now, and subsequently to that I've worked on it for the last 10 years, developing it to the stage we are today.
And why Kell? What
Kell? Well, what do you call a process? That's actually the hardest part of the whole thing, and you can either give it a name like Plat-Ox or something like that, a technical name, or if you look at Merrill-Crowe process or Bessemer process, they're named after people, so I just named it after my initials.
Oh, fantastic. So that's
KL.
Okay. And more important, what are its benefits?
Well, there's quite a few, but the major one in the context of South Africa at the moment in the last 3 years is the reduction in electricity consumption. Smelting consumes somewhere around about 1,000 kilowatt hours per tonne of concentrate smelted. The Kell process consumes 140 kilowatt hours per tonne of electricity. So there's the one benefit there, and if we look at electricity since 2008 has gone up 260%, it's going up another 16% in April. There's cost reduction there for a start.
So is that real? You're saying it consumes 14%?
14%, and the reason is we don't melt the concentrate. So we put a bit of coal in to heat it up in one stage of the process, and the rest of the electricity goes into pumps and agitators.
And does it work at laboratory scale?
Well, I've spent the last 12 years proving it works at laboratory scale and perfecting the process and the engineering of the whole thing. And we recover 99% plus of the platinum and 98% of the other PGMs as well, and the copper and nickel.
And who has audited its performance to say that it does work even at laboratory step?
It's been audited a number of times, and that's very important to me as an engineer. You have to have peer review processes. It's been audited. Fatal flaw analysis was done by Bateman's a while ago, and they concluded there was no fatal flaws in the fundamental chemistry and engineering. I've had a couple of independent engineers do scoping studies for capital and operating cost determination. We actually have the whole thing running under a very sophisticated chemical and energy modelling system, and we're just going through a peer review process now that'll be finished at the end of April, again just to audit where we are at the moment.
And when will you know the big question, whether it's going to work at commercial scale?
Well, we've been running pilot tests last year. We're about to start another large pilot scale test in April or May over in the laboratories in Perth. And following on from that, there's a definitive feasibility study starting, and if all of that comes to fruition in the next 6 months, we could be moving to construction towards the end of the year on a 12-month construction phase.
And just repeat that again about the electricity again, because you know, it doesn't sound credible that it only uses 14% of the electricity that the smelting process uses.
Well, in the smelting process, every portion of the concentrate, and the concentrate consists 90% by weight of minerals that have no value, the silicates and the chromite. It raises smelting raises the temperature to 1600 degrees and then melts them, and the PGMs drop out in what they call a matte. In my process, we take the concentrate, and all we do is we leach out the valuable metals, the base metals and the PGMs, and that 90% by weight of the waste product just moves through the process without actually being changed at all, and it comes out the end in the same mineralogical form as what it went in. So that inertness of the waste metal, of the waste minerals, means that you don't consume energy in doing anything to them. It's that simple.
And then greenhouse gases is a big issue of the day.
Well, yeah, when you look at electricity consumption, for every kilowatt of electricity generation, you produce about 1 kilogram of carbon dioxide. So smelting consumes 1,000 kilowatt hours a tonne carbon dioxide, and you add in the other slag cleaning furnaces, milling of the matte, to smelt a ton of concentrate through to matte and base metal refining produces about 1,400 kilograms of CO2 per ton of concentrate. Again, because Kell, we consume less electricity, and in fact we don't do any milling in our process. We only produce about 440 kilograms per ton. So 1 ton of carbon dioxide per ton of concentrate treated. And if you think concentrate treated is probably 2 million tons a year going through smelters, that's a lot of carbon dioxide not going up the stack.
But smelting is so integral to platinum group metal processing. It's almost part of the furniture. Would you have dared to do this if South Africa was in its old position and had an abundance of electricity? I mean, what I'm trying to say is it really a compelling case, or only a compelling case in the context of the scarcity of electricity?
No, it actually has other benefits, because the Kell process, it doesn't matter the grade of the concentrate going in terms of PGMs, it doesn't matter the grade of sulfide, and more importantly in the context of processing the UG2 ore, it doesn't matter how much chromite you have in the ore. And if you look at smelting, the smelters battle to handle chromite in the UG2 concentrate, and all of the specs, if you sell concentrate to the smelters, the specifications of those contain maximum levels of chromite in your concentrate. So you have to run your flotation plant to meet those specifications, which means that you lose recovery in the flotation plant. We completely take away that constraint. So you can add about 5% extra recovery of platinum to the flotation plant, which means your overall recoveries actually through the process of mine to metal are increased substantially as well. So Kell will never replace smelting, I don't think, because that's sunk capital that is sitting there, so it should never make that capital redundant, but it will sit alongside smelters, processing the lower grades, concentrates and more hard to treat. But importantly for juniors, they can now put a Kell plant on their mine and produce metals, so there's beneficiation that we're looking for.
But what about new enterprises coming into the market now? Do you think, even if they are a major producer, and it looks like, you know, the company Newco that is being introduced by Brian Gilbertson and Arnie Franson is going to be a major. So is it, can it take the step retrospectively, or should one start from scratch with the Kell process?
Start from scratch, because the economic size of a smelter is 500,000 ounces or more. Currently the existing operation of Platmin, which sells its concentrate to Northam, that produces at full capacity about 250,000 ounces, so not enough to build a smelter. We can put a Kell plant next to that plant. As they mine another pit and put up another concentrator, there's a modularise and stick another one. So yeah, we can grow up to their 750,000 ounces planned output just by putting the Kell plants down as they need them, so they don't need to sink all of the capital now into one big smelter that can take 750,000 ounces. So no wasted capital spent too early. That's a compelling factor.
And smelting is a good recovery process. I mean, we're talking about 98% recovery, talking about 99% recovery. You're talking the same figure. So you toe-to-toe
exactly
with smelting on the recovery.
And that's very important. If I couldn't have perfected the process to give us the 99% plus recoveries, then when you add it all up and do the economics, then you lose in recovery. But don't forget, I can get 5% increased recovery off the concentrators because I take away the grade constraints that the smelters have.
So just repeat then, in what respects is smelting superior to Kell? Where would you go for smelting? Where would you not go for Kell?
It already exists, so in that respect it's superior because it's sunk capital. So you never close down something that's effective and efficient and everything else. So it'll never replace those smelters. But gradually, as new operators come in, then Kell plants can go up on the mine sites. So efficiency-wise, they're pretty much the same, but in terms of platinum recovery from the concentrate. But Kell gives you a lot more flexibility, and the size of a plant that's economic is a lot lower. So for example, if we replace a concentrate offtake agreement where you only get paid, if you're lucky, 80% of the value, with a Kell plant where you can make the metals on site and you can increase your recovery by 5% in the concentrator and run the economics on that, payback on scoping studies we've run on those is less than 2 years. Very economic.
But what if the majors say to the juniors, now look, we won't give you 80%, we will give you 90%. What if they change their position because they've now got competition?
Well, that's always up for them to do on their business cases. But if you look at the strategic value of juniors making their own metal and beneficiating all the way down the route, there's also a reduction in royalties, because you pay royalties are two-tier. If you sell concentrate, you pay a higher royalty than if you beneficiate. There's also beneficiation credits that sit under the mining licenses as well. So there's spin-off benefits there. But I think the strategic value of a junior producing his own metal within a week of mining it, instead of having paid for it 4 months later on a concentrate agreement, just the value of reducing that cash lockup when you run the economics is compelling as well.
When should Kell not be used? Is there a no-go area for Kell?
We haven't found one at the moment, and I've tested, it's almost a dozen concentrates containing PGMs from South Africa, and that's UG2, Merensky and Platreef. But we've also been testing concentrates in North America, US, Canada, and also Scandinavia, and they all give the 99% platinum recovery. That tells me it's robust for different mineralogies. So we haven't found one yet, but I'm sure there's one out there. But always a no answer is as important as a yes answer. But we look at the mineralogy of the concentrates, and the Kell process is designed for the mineralogy, and that's what makes it robust.
And when is its application really optimal? What is a compelling time when you shouldn't look at anything else but Kell?
If you're producing 250,000 ounces or less as a new mine starting up, or you're currently selling concentrate to one of the majors, have a look at it, and we're talking to people about that already.
And how does Kell help the junior miner? Can you just go through that stage again?
Well, the junior miner, he operates his mine, he builds a flotation concentrator and makes a concentrate that contains the PGMs and the base metals, filters it, and then he trucks that to one of the smelters. What we can do, and he gets paid 80% roughly for the value of the metal. We can put up a Kell plant next to his flotation plant in the same area, similar facilities of assays and operators and everything else. Instead of trucking his concentrate, it comes out of the float plant. We don't even have to filter it. We thicken it, we take it in, and out of there comes either the metals or 65% platinum concentrate that he can then go and sell to a refinery, or he can then turn it into autocats if he wants to, because we have the PGMs in solution at that stage. You can turn it into the product you want. And with paybacks of less than 2 years on that capital, internal rates of returns of over 70%, the economics stack up.
But how much is it going to set him back now? The normal, I'm talking about a standard-sized Kell. You've come along to this junior, he's got those circumstances which you've just described. How much money is it going to set him back to set up this plant?
To add that into the Kell process and plonk it onto either an existing operation or integrate it into a new one at a capacity of about 250,000 ounces a year of PGMs, which is about the junior size, but a large junior size. Capital cost that we're running on our scoping studies is about $65 million.
But along comes Jubilee with its con roast, and it says, look, that's what I'm here for. I'm here to help you juniors. How would you present your case that would be compelling for a junior in competition with Jubilee's con roast?
Well, fundamentally, I'm an engineer, so every process must stack up on its combination of technical risk, economics, and then strategic views of the mine owner of producing metals. Con roast is out there as a technology. It's a smelting technology, so it is 1,000 kilowatt hours a ton roughly consumer to do that. So my view is the owner does the test work. We run the studies for costings and OPEX. It goes into the financial model, and the best process always wins.
And what is hydrometallurgy, and how does it differ from pyrometallurgy?
Well, hydrometallurgy is liquid metallurgy, so it's leaching. So we take the concentrate. The first stage is actually a leach with sulfuric acid, where we leach out the base metals, the iron, the nickel, the copper, the cobalt, and we don't leach the PGMs. So the base metals go away. The solids carry on into the second stage of the process, which is a heat treatment, where we treat the material so that the PGMs are rendered soluble to the third stage, which is a hydrochloric acid leach, which is the first stage of platinum refining, so it's something the industry understands already. We then leach out the platinum group metals. They're in solution. We purify the solution and refine it or precipitate it, and the products we make go straight into existing base metal refineries or PGM refineries, or as I say, you can tack your own PGM refining on there. Pyrometallurgy is heat metallurgy, which means you heat it all up and melt it. It's the sledgehammer to crack the nut, in my view. Hydrometallurgy is a process that is used elsewhere around the world in the base metals industries, and we've just taken standard pieces of equipment and processes from other parts of industries, metallurgical industries. So there's no new equipment in this process. We give a design package to engineers, and they go and design an autoclave and all the other equipment, and it's all essentially off the shelf or out of the catalogue or made to order by engineering companies that built these things before.
And if sulfide flotation is not used, can you still apply the Kell process?
Well, flotation in PGM and base metal metallurgy is always used to concentrate the materials from the ore, and the economics of whole ore leaching is something that the price of the metals just don't warrant at the moment. So you always, in my experience, have to have the flotation concentrator sitting there, and that's where you lose a lot of recovery. Flotation concentrators can have recoveries of 80 to 85%. Because they are constrained at the moment by the grade that has to go to the smelters. So we say you can drop those grade constraints and you can pull more concentrate, which means your recoveries are high, and that's why we can increase those flotation recoveries by an extra 5%. So when you look at mine to market, although on a concentrate we're the same recoveries as smelting, when you look at mine to end product, we're 5% higher in general.
And you say Kell can deliver high value concentrate, and you gave also can deliver final metal, or what I've found difficult to understand, can produce added value products like auto catalytic converters and fuel cells. I mean, that almost sounds as if you've got a CAD-CAM add-on.
Well, essentially it is, because as I explained, the third stage of our processing is the first stage of a PGM refinery, which brings all of the PGMs into solution. So we have those in solution, and so you can say, well, I can add on my bits, so how much capital do I want to spend? The simplest way is just to make a precipitate, an oxide that contains 65% platinum, 30% palladium, the rhodium and everything else. That can go to PGM refineries in South Africa or around the world. Or I can then split those, I can say I want to split those PGMs out, and I can want to make the metal. So you add on the next box of process, which is what they do in the PGM refineries, and split them out. Or I can say, I've got my platinum in solution, I want to make some autocat. So you can then take that solution and add an autocat manufacturing plant on the end of that as well. So it's up to, because we've got, and that's the value of hydrometallurgy, is we have everything in solution in a form that you can then decide what you want to do with it.
So you're saying you can eliminate the smelting process, but you're giving me an indication you can eliminate the refining process depending on what you want to do with the product.
No, we don't eliminate it, we just bring it into the Kell process. So we take that refining technology and add it on the back of the Kell process.
So you can actually have a refining segment to this as well, which will mean you won't have to go to one of these large bespoke refineries.
Exactly, yes. And
that is huge.
Yeah, it's amazing. And when I start to think about the possibilities, I get far down the process stream, and I've got to bring myself back up to the front end where the focus needs to be at the moment.
So we're saying we've got this high value concentrate if the client wants that, and then the plant will be of a certain configuration.
Yes.
But then you can go along and deliver final metal.
Yes.
But that's not refined metal.
Yes, it is refined metal, because the PGM refineries are actually hydrometallurgical refining operations, with maybe some little kilns and that in there. But basically, it's refining of solutions. It's not refining as pyrometallurgical refining.
So you would then have to have the equipment to produce platinum bar or whatever you wanted.
That's right.
It could be an add-on situation as well. So you could have this whole aspect of concentrate to market in different forms.
That's right.
Depending on what you want to invest in the actual Kell system.
Yeah.
And you can even go to the fact that you could produce fuel cells there. So we're talking about a possible Silicon Valley for platinum.
Exactly. And that's what we're looking at, sort of in the vision that I think Brian Gilbertson and Pallinghurst and the IDC have, is where can we take this to?
Sure. So it's a very interesting horizon
Yes.
that you've introduced here. And then can you tell us something about yourself and how you arrived at Kell? Well, you've told us of how you arrived at Kell, but about yourself, because it's not easy to, come up with a solution like this, which sort of goes against what people have been doing for so many years.
Well, I cut my teeth in the platinum industry. I graduated in 1981 in Birmingham University with a degree in minerals engineering, and as a lot of us did then, we got on a plane and came to Johannesburg, and I ended up working at Mintech, and it was the lowest paid offer, but I thought at least at Mintech you see the South African mining industry, and luckily I did. And within 2 weeks I was working at Western Platinum at their first UG2 concentrator that was put up, optimising its flotation recovery, and I carried on through working primarily in the platinum sphere in my time at Mintech in the 80s, and I then left Mintech, and at Mintech developed a fine grinding technology that was licensed from Mintech into a company I set up, and then spent 6 years developing and selling fine grinding mills into the industry. So again, technology development, but heavy equipment development, and that took me to Australia in '94. 96 I was back consulting to Aquarius Platinum, and then ended up as the MD there in 97, and then we put the Kroondal plant, designed and built Kroondal, and Aquarius sort of became what it was, and that's where I started looking at the Kell process because of that, and then moved from Aquarius into resource investment, so running a company that invested in resource companies and financed them. That got me into Platmin, and I've been working in Platmin, and I'm still deputy chairman of Platmin since 2003. So my whole career I've had at least one foot in the platinum industry, and at the moment it's both feet well planted in that. And Kell has been running along sort of in the background. As I've had funds, I've been developing it, and but certainly the last 3 years has accelerated because the interest is there and the need is there.
And how much have you invested in it personally, and how much do you think you can yield out of this?
How do you value time? But in terms of monetary investment that's gone in there, it's getting on for $5 million worth of. A lot of that has been my funding, and I've now got a few backers there that have given us the funds last year, which meant we could accelerate a lot of the in-house design and engineering work.
So you own the intellectual property on this, you own the patents, but you have a company that owns Kell at this stage.
That's right. All my intellectual property and rights to the patents are in a company called Lifezone Limited, which is a Mauritian company, and I'm the major shareholder in that, my family, with three other individuals in there, one of whom is the chemical brains behind the whole thing, Dr. Mike Adams, who I worked with Mintech in the 1980s. He's a double PhD in chemistry, and he's the secret behind all of the stuff that I don't understand. So he's the chemist and I'm the engineer. So say to Mike, come up with a process and I'll turn it into the nuts and bolts.
And if I was sitting here in 10 years' time, pretend it's 2022, and I'm talking to Keith Liddell again, what do you think, how deeply will Kell have penetrated in your expectation?
I think we will hopefully, and if it all goes to plan, we'd have half a dozen plants up and running by then in some of the new entrants into the market, and in some of the existing producers, treating some of their lower grade tailings retreatments or second stage UG2 flotation concentrates that are low grade but high chrome. And so we'll have greenfields Kell plants, and we'll have Kell plants sitting next to smelters. I think it'll be a combination of the two. But the smelters will still be running, but they'll be running on feed that's more suited to the pyrometallurgy. And
do you anticipate that it may spark what I used, probably a grandiose term, a Silicon Valley for platinum? Could it spark something? Could it aid and abet it?
I would hope it does, because I think if you look at, we produce 70% of the world's platinum here, and we don't make 70% of the world's autocats or fuel cells or anything here. So I'd like to see that it does sort of spark that up, and definitely in that regional development that we're talking about up in the Pilanesberg, there's definitely potential to have that sort of silicon type valley sitting up there, and Kosipalani of the Bakgatla-Ba-Kgafela tribe is certainly keen on looking at all of that. And I like the fact that we can import this hydrometallurgy skills and all of these things into that region and create sort of skilled jobs, not just sort of menial type jobs in there. So it's definitely could be something that's on the cards. And if you don't have a vision, then there's, what's the point?
That was Keith Liddell, the inventor of the Kell process, which mining luminaries like Pallinghurst chairperson Brian Gilbertson and the state-owned Industrial Development Corporation believe can open the way for adding value to platinum and spare power utility Eskom the job of continually having to spend a fortune on more power station capacity.
Thank you very much.
Thanks, Keith.